Hi class, we're going to continue our discussion in chapter 12, expanding our knowledge on correlation and learning about regression. As a basis to start, let's go back and see what we had discussed previously. Correlation is something that tells us, is there a linear relationship? So we would have two variables. We would have two variables, our input, maybe x, and our output, or response variable, y. And we would look to see if there's a linear relationship with these two variables. Once we know that there is a correlation, then we can talk about regression. Regression describes this relationship. Now for this class, we're focusing on linear relationships, but as mentioned previously in class, we could have quadratic or cubic or logarithmic relationships. And just a reminder, regression is used for predictions. So how are we going to describe this linear relationship? How are we going to make these predictions? Well, we would use something called the regression equation. The regression equation is usually known as the line of best fit. Let's take a look at the scatter plot that we have in the upper right-hand corner here. We see a positive correlation, and what the line of best fit will attempt to do is get as close to as many dots as possible. You're not trying to hit as many dots as possible. You're trying to get as close to as many dots as possible. So that means it would probably look like it goes through the middle. Now, if correlation is assumed, so if there is correlation, then our regression equation known as y hat is our line, mx plus b. Statisticians tend not to write it in the form that we've seen in algebra. They tend to write the y-intercept first and then write the plus mx. But we know with addition that it could be written either way. If there happened to be no correlation, so if the dots were just all over the place, as we saw last week, then we won't use the regression equation because there is no correlation. What we would use to make our predictions is y bar. Now, we'll conclude this short video here with our discussion on how do we find slope and how do we find the y-intercept. We're not in algebra anymore, so those formulas are not going to work for us. To find slope, we would take our correlation coefficient, which is r, and we would multiply it by the standard deviation of the response variable of the y's divided by the standard deviation of the input or explanatory variables x. How would we find our y-intercept? We would take our y bar and we would subtract the slope that we found above and multiply it times x bar. So this outlines the direction that we're going here in this section. And then within class, we'll get into specifics of how to calculate this and a little bit more on what these values mean. All right. I'll look for your questions on the discussion board, and until next time.